we will you will meet in, but I will tell you, I just tell you if for example I will show you like this one. For example, if in one exercises you need a cycle, and I think I will be tell you which kind of a cycle you should. For example, here, this one. I say here, what is the difference of different cycle? And I will not give you such kind of question. I will give you, for example, if in the exercises, in my final exam, I will ask you, what is the difference of the Otto cycle and or diesel cycle? Okay, I will give you the specified, not only just like this one. What is the difference between different cycle? Okay, and but here, for the Carnot cycle, maybe I will not give you. I will not ask you try to use the Carnot cycle to solve this problem. I will not tell you because do you know why? Because if the application, what is the application of Carnot cycle? Is we can use the Carnot cycle to judge a process. Is it possible or impossible? Do you remember? Yeah. So I just ask you, and there is a process, and maybe absorb some heat or do work to the surrounding like this one. And then I ask you, do you think the process is possible or impossible? So I will not tell you try to use the Carnot cycle to solve this problem, but you should know. I think if you made questions like this, to ask you whether the process or cycle is possible or impossible, whether the process is reversible or irreversible. I think you try to think here the Carnot cycle, the HB generation and the flow, and the closures in equality. Maybe these two knowledge you can use to solve that kind of equation. Okay, it's okay. I think if you still have any other question, I think it's okay. We can still have a discussion. Okay, because we need to finish our exam in our next week, and I hope you all can get high score. Except I cannot give you the I cannot give you the exercises. Any other questions we can all discuss. Yeah. I just say the calculations is from the PPT. The journey is from the PPT. It's also from the PPT. And the certification, yeah, it's also from the PPT, but I didn't, in some PPT I didn't give you the answer, like the calculation. In some calculations I didn't show you the answer, but I write it here. Okay, but I think it's okay for you. Okay, so now let's try to today we still need to finish these two exercises, exercise 4 and 5, and there's a lot of exercises here. Maybe this one. Sorry, which? Here. Okay, let's start this one firstly. You can try to do it. Okay. Sorry, here is a mistake. So, what is you trying to? Okay, I think this one is a little hard. Okay, but you can try to think. Honestly, I don't think we will have such similar exercises in our final exam, but this one will help you a lot, I think. Okay, if you can solve this question, I think you can solve all other similar one. Okay. Sorry, sorry. Which one? Okay. You, so you what you mean? You think it is too hard? No, I think you the reason is you didn't find uh, you didn't find the right solution. I think maybe I will tell you. I think. And do you still remember the equation table? I tell you, I show you an equation table. If you find that table, and then you can solve this question easily. Okay, if you cannot find it, I think it's hard. It is will be hard for you. Okay, I think this one is a little hard for you. I will show you the answer. Okay. Okay. Oh, sorry. Why? Why? Oh, what is the matter? Sorry. Okay. Here. Uh, Here is the answer. Okay, try to understood it. Okay. As we know this is a polytropic process. Under the T1, T2, V1, V2, there is a relationship. You maybe ask me why? I don't know why also, because this equation is come from the equation table. Okay. Of course, if you really don't know why, you just try to use the state equation and the process equation, and then you can get this one. Okay. You know, when we get this equation, then we can get the solution of the n, and the n is equal to 1.475. Okay. Maybe this one is a little hard for you, so I just tell you we will not have such a complicated you can science in our final exam. But for example, if I give you exercise like this one, I show you V1 divided V2 is equal to 100. You please don't ask me why we can get a high pressure, not the pressure, the this one is so high, you do not try to ask me why, because I just want you to make your calculation simple. I hope you can understand. Okay. Okay, and now when you get the n, after that we can use this equation. This equation is also comes from the equation table. Use this equation, and then we can get the R, get a result. Okay, after that, then do you remember this equation? This maybe is the equation in closed system. Yes, for the first law of okay. And then, do you know why here? So you need to know how to calculate the delta U. And we know du is equal to cv dt, dh is equal to cp dt. So you should know how to calculate the u and h. Okay. Now if we get this equation, then we can calculate the CV because we know the W, and then we also know the Q, and the T2, T1 we know. Then we can use this equation to calculate the CV, and then after that CP. Okay, this is the equation. We know CP is equal to CV plus R. Yes. Yeah, so we can get the CP, okay? And I give you just maybe 1 minute to review it, okay? I just tell you, we are not have such kind of complicated exercises, but I mean, why I think this equation is complicated? Because its calculation is complicated. I don't mean the process is complicated. So maybe in our class, in our exam, you need to use these equations. Okay. Maybe I mean, like this one is not important. Okay. This one is not important. But maybe I will try to change this value, and then you need to employ some kind of equations. Okay. Okay. Okay, I think it's enough. Let's go to the next exercises. Okay, this one. I try to explain it. Okay, 1 cubic air and the Baltic expanded from state 1 to state 2. We know from state 1 to state 2, the process is expansion, and the adiabatic process. I don't know if this translation is right or wrong, but I hope you can understand it. Okay, adiabatic expanded from state 1 to state 2, and then caused the thermal compressed to state 3. As we know, state 2 to 3 is a compression process, and the process is a constant thermal. Constant thermal, what is constant thermal? Thermal is maybe adiabatic also. Yeah, thermal, what is thermal? Thermal is Q. Why is thermal? What is thermal? Thermal is maybe this is a I'm not sure. I need to. Why we translate it? Wait a minute. Okay, because I don't think constant thermal is adiabatic. Maybe it's yeah, but we. Okay, is temperature here is okay. Okay, now and then it's right. Which you mean here is right. This is a constant thermal is a constant temperature. Yes. Okay, and the constant is a constant thermal compression process. Okay, if we know that P1 we know, yes, and V2 the relationship between V2 and V1 we know, V3 the relationship between V3 and V1 we also know, and then we need to try to find out all state parameters PV and T. and the state 1, 2, and 3, and the work of the air in the whole process. Okay, I think this is quite, quite important, for maybe simple and and easy to calculate. Okay, so try to do it. I think you need to find the equation table. If you don't find the equation table, I think this is hard for you. But if you find it, I think it's easy for you. Okay. Because today we still don't have enough time. We still have another exercises. So I will show you the answer. Okay. Like this. I hope you can write it clearly. State 1, state 2, and state 3. And I will know, okay, PVT we all know in state 1, but we don't know the P2, P2, but we know the V2. And state 3 we also know, don't know the P3, T3, but we know the V3, okay? And we know from state 1 to state 2 is an binding process. And from state 2 to state 3 is isothermal process. And if we know this one, we know for state 1 to state 2, we can use this kind of equations. Okay. You should know, because I found you don't know. I don't know why. But I hope you can know how to get these equations. Okay. And then we can get P2, T2. And also from here, from state 1, state 2 to state 3 is as a thermal process. Then we can get this kind of equations to calculate the P3, T3, and then I hope you can try to write the results like this. Okay, and this will make others to understand you quickly. P1, P1 V T1 and P2 V2 T2 P3 V3 T3. Okay, like this one. Okay. I think at least I hope you can get a right answer of this part. For this part, maybe it is a little hard, but just a little hard, not hard for you. Okay. Because you should know this equation. Okay. From 1 to 2. This equation, I think maybe for you is a little hard at the moment, but I don't think it's hard for you in the future, okay? Because if you get the equation number, equation matrix, I think it's hard, it's easy for you, okay? It's easy for you. And then finally we can get a result like this one. I hope you can try to solve this question after class, okay? And finally, there's a lot of exercises. Okay, the final one is this one. Okay, this one is also hard for you, I think, but I hope you can know. You can try to use the entropy generation and entropy flow to solve these equations. Okay, and then I will give you about 10 minutes. Okay. You just try to answer these two questions. Okay, this one we did not learn in our class. Okay. Because in our plan, I tried uh, to talk about the lots of working ability, but we don't have enough time now. So I think it's okay. It's okay for you. Okay. So you just try to answer these two questions. Okay, 1 and 2. You don't need to answer the third question. If you get the right equation, and then this is simple. But if you didn't find the right equation, you don't know how to solve it. Try to think it, and a few minutes I will tell you. Okay, okay. So, did you find the right? Yeah, this is the last PPT. Yeah. You don't have this one? Oh, it's okay. I will give you tonight. Okay. Okay, I will give you tonight. Okay. I will try to give all my PPT to you tonight. Okay. Okay, I think maybe I don't know whether you find a solution now or not, but try to here. Our question is which set of data is right? So which set of data is right? Which data is right? We didn't discuss this before, yes? But do you think if I say, do you think the process from state 1 to state 2 is possible or impossible? Do you think this process is reversible or irreversible? So now I think you know what kind of knowledge we need to use employed here to solve this problem. Maybe it's a Carnot cycle, closures inequality, and maybe it's the entropy flow, entropy flow and entropy generation. Okay, try to think or review for the Carnot cycle, which is the heat efficiency eta is equal to 1 minus T2 divided T1. Okay, and I don't think we can use employ the Carnot cycle here. Yeah, and for the closures inequality, do you still remember the closures inequality? It may be like this one. Yes. Yeah. So if we get this one, if we get delta Q, maybe like this one, okay, it's bigger than 0, and then the process or the cycle is impossible, okay, and it's equal to 0, and then we know it is reversible. But if we less than 0, and then it is irreversible. And do you know there is any heat here? No, I don't think there is any heat. Can you find any heat? No, no. So I don't think we can use this one, okay? So maybe we need to use this one. Yes? The S. What is the S? Do you know the S? The entropy is maybe is equal to the entropy flow and then plus entropy generation. We know if the entropy generation is equal to 0, and then the process or the cycle is reversible. Yes, and if this one is greater than 0, and then it is irreversible. But if this one is less than 0, that's impossible. Yes? So maybe we can employ this here. Yes? Why? This is a T1, P1, and T2, P2, T3, T3. So do you know how to calculate the data S? Do you remember the equation for calculating the data S? So I hope you can remember this one, okay? So ds, oh, maybe we can say S2, S1 minus S1 is equal to Cp T2 and maybe R. Sorry, I forgot it also, but I need to get help from the book, okay? Okay, maybe it's P2, P1, okay? So, you know, then this means we can obtain the S, because we know state 1, state parameter, state 1, state 2, yes? But maybe you see, oh, because we know the S, but this is not the SG, yes? But this is what kind of process? So it is an adiabatic process, which means for adiabatic process, which means SF is equal to what? You are right, just you know, you are right. 0. Okay, 0. Okay, so now we can try to solve the problem like this one, okay? And because S, okay, S is equal to SF plus SG. And then for adiabatic process, theta Q is equal to 0 for this one. And then we know SG is equal to S. Yes? And then S is here. Maybe we can say delta SG is equal to delta S, okay? And delta S is equal to CP, like this. Yes? And then we suppose, okay, if T2 and P2 is right, okay, if this set of data is right, and then we can try to delta SG. Delta SG is the results is delta SG is minus like this one, okay? Like this one. So give me the answer. Do you think this one, this set of data is right or wrong? Why? Maybe you will ask me why. This is from here. BP is here. Okay. Okay, maybe it's a little. CP here, and the T2 400. Maybe I write it here. Okay. Maybe it's like this one. 400 and T1 is 800, and then R is 287. P2 is 1, and the P1 is 5.5. Yes. Okay. And then we can write it like this. Okay. Then is equal to so give me your answer. Do you think this set of data is right or wrong? Impossible. Yeah, it is impossible. Because we know the data SG need to be greater or equal to 0. Okay. And then we know this is wrong.
Laushi, we cannot see the board.
Yeah. So I heard. Okay, next. I don't think you need this one. Because data SG is less than 0. So because okay. Yeah, because data SG is less than 0. Hence, it's impossible. Okay, because we know data SG needs to be greater or equal to 0. Okay. No, I think maybe. So you. So wait a minute. Okay. Wait a minute. Oh, thank you. Oh, sorry. Can't hear. We get a wrong equation here. This one. Yeah. Is minus. You're trying to change it. Minus. Yeah. Oh. Yeah. Sorry. Okay. Sorry. Here this equation is wrong. Okay. Sorry. This one here is minus. Not. So try to get the right equation. Sorry. This one is minus. Yeah, it's minus. This one here is minus. Okay. So, but all here is right. Okay, all this one is right. Okay, and then we know for this set of data it's impossible. What? We just ask which now we just try to which one? Why is this equal to 0? If SG is equal to 0, which means it's a reversible process or reversible cycle. Okay. Right? If SG, or maybe we can say data SG is equal to 0, and which means the process is reversible. But if the data SG is greater than 0, which means the process is irreversible. But if the data SG is less than 0, this is impossible. This is impossible. Okay, so for the second set of data, it's impossible. It's impossible. And then we can try to calculate. Suppose, okay, we suppose T3 and P3 is right, okay? And we try to suppose this one. And then we can also calculate the data SG, but then it's CP like this one. Maybe it's like this. T3, T1 is equal to like this one. T3, 495. T1, 500, and R is 287. P3 is 0.7 and 5.5. And then we can get a result. The result is maybe it's 109.7. Yes. Yeah. Okay. And then we know here data SG is greater than 0, and we know it's possible. And we also can ask the second question. It is irreversible process. Yes. So it is irreversible. Okay. Irreversible. Okay, you should know this. For this one, I said just now you don't have to know how to calculate it. Okay. And that's all for today. If you still have any other questions, do you have any question? No, okay. If you have any other question, we still have time to discuss it. But if you don't know, I think we can finish our class today now. Okay. So please try to come here on time the next week. Okay. And then try to prepare our final examination fine. Okay. Then again, good luck for you. Okay, that's all. Thank you.